Everybody hear me all right? Yep.
Hey, Joe.
Oh, good.
There you go, mate.
Good, Colin. How are you going? Derek, did you find out your results by any chance, mate?
Nothing yet. Nothing yet. So
Oh, okay.
still waiting. Yeah.
All right.
I don't know.
Well, that's strange. Most everybody else heard they got their results, yeah? Yeah, okay. So this morning, guys, what I want to go through, did we go through the review questions on 1554 part 4?
Not yet.
We haven't? And I want to go through that WPS as well. So I want to go through that. Before we kick off on 1554 part 5, I think you're starting to get the understanding now, guys, that the way these are set up, you know, there's the only difference is now is it's very specific on a little bit of extra information. But, you know, the tables are almost in the same place. You know, it might be a page difference or two, but everything is formatted exactly the same. There's no, you know, what you're seeing is they're almost word for word from each one. You know what I mean? From 1554 part 1. But when you do start looking through this series in particular, I mean, with this one in particular today with fatigue loading, you're still going to have to reference your 1554 part 1 for your GP and your SP anyway, because this is mainly on the fatigue purposes. And what you'll see in this particular standard today is we have the ability here to blend welds and change their profiles a little bit because of that fatigue loading, that stress related issue where we now can blend them and do these sort of things. So that's what this is really concentrating on, really on. And it's only if you're going to be doing that sort of work. Remembering too, that you aren't the one doing the designing side of this. You know, you are there just to check it all and clarify that the wells are to what they are. If there's any blending or anything that you do, you know, you look at that and do that. So that's what you've got to look at. All right, what I want to do then, we'll start off with going through those review questions on 1554 part 4. And what I want, the first question was, what well categories does 1554 relate to? And I think we're pretty well, when we're looking at our well categories, we know it's our GPSP. And in that case, in this one, it was also mentioning FP. All right, so if anybody can tell me where they found that in the standard, what notation?
So it's clause 1.6.
Correct.
ABC.
Thank you. Throat thickness of a completed butt well shall be. And now I want the notation.
3.2.2.1.
Perfect, Ben. Thank you.
Same.
Yep, that's it.
So what does it actually mean, Joe?
So what it means there, the throat thickness of a completed butt well, the thickness of the thinner part. So if we're looking at your material thickness, it's got to be within that throat thickness has got to be a minimum of that. So what you're looking at, when you look at your butt welding, for instance, and you say 12 mil, depending to how much penetration is there, because you've got your effective throat thickness when we can work out the throat, the actual penetration in that as well. But what it means is we can't be any less than our material thickness. So then we start looking at how much reinforcement is. In other words, if we were to completely grind the weld, and it's very specific in the standards on how much you can grind. Remember, you can't go below a certain level. So the thickness of the thinner part. So if we're doing say a butt weld, for instance, and we've got two, I'll draw it up. We've got two pieces. Okay. If you have a look in your stand, you'll also notice that there's butt welds there where we have pieces that are transitioning where they go thicker. You know what I mean? So in that case, then your throat thickness has to be of the thinner the material, not the bigger one. Does that make sense?
Yeah, it does for a single. Is that the same for a double V?
Well, a double V will be slightly different anyway. So, but you'd be still looking at your throat. Well, with your throat thickness there, you've got both, you know, you're covering that full joint. So it is the thickness of the material. So if you were doing say a double butt weld, but say we had a piece that was transitioning, which was a lot thicker. All right. say it's a butt weld, say for instance. So we'd still be looking at the throat thickness on this one has to be the minimum of that one. You with me? So, and then when we're talking about grinding and flush, it stipulates in the standard, you know, the allowance, because we all know a lot of the guys that we work with are very aggressive with the grinder. So depending on the standard you're working to and what weld category, you've got to be aware of that and make sure that the guys are adhering to the standard. You know what I mean? So you might have to do a bit of controlling, you know, when you get into this role and you start, you know, monitoring guys and that, and it's just making sure that they are doing the right thing. All right. With question 3, what is the minimum size of a 6mm fillet and the table?
.3.5.
Yep.
And 3 mil.
Correct. So you'll find that same table is running through all the same, is in the same sort of same table number, and it's in each of the standards. So really, it's like they've just copied and pasted information from 1554 part 1, transferred it through to the rest of the series. But what they've done is they've added the extra information, particularly to that whatever standard we're looking at, like quench and tempered or fatigue loading and that sort of thing. What you'll find, and what I want to do too today, guys, I meant to mention it last week, explain that LOD map in the back of the standards for you as well, give you an idea what that's all about if you're unsure. I want to go through that as well. So the next question was, the parent material shall have a minimum yield strength not exceeding, and then a notation. They shall not have, yeah,
2.1.
Yeah.
It was 2.1A.
correct. Well done, guys. Starting to look like you're finding your way around. All right, question 5. The joining of quench and tempered steels to structural steels shall be carried out in accordance with. So notation.
I had 2.1C when the Australian Standards ISO and the others listed.
That's good, Anthony.
Right.
The other thing is,
I had 4.1.1.
in 1554 part 1.
Yeah, it says in accordance with 1554.1.
Correct.
Notation was 4.1.1.
Correct, Ben. Well done. Yep, that's excellent. Okay. Really good, boys. Really good. Question 6. A procedure qualification on a double V also qualifies. Notation.
4.1.2G.
Correct. So a single butt weld that has been welded from both sides. So good. Number 7, a procedure qualification of a fillet weld using the process on either plate or pipe. Notation.
4.1.3A.
Well done. Good. Question 8. Do welding procedures using self-shielded flux core consumables in combination with other consumables compliant? Notation.
4.12.2B. Yes, metal core T15 or not?
Anthony, what I got here, I've got 4.3.2 and are deemed non-compliant and require requalification.
Yeah, that's what I had too.
Well done, Ben. Yep. Have a look at that, Anthony, for me, and have a look and see where it is. So 4.3.2.
Yeah, mate, 1 sec. 4.3.2.
Yep.
Oh, yeah, non-compliant. Yep. Welding procedures, self-shielding, flux cord.
Yep.
Yep. No worries.
Okay. Good. Question 9. The allocation of steel type numbers to particular steels is given in just a notation or a table.
Is that table 4.6.1B?
Correct. Well done. Okay. Ben tests that are required as part of the weld procedure qualification process preparations welded as T-joints or corner joints should be welded as. So we're looking at T-joint or corner joint.
4.7.1. No, 4.
Well done, guys. Good. Excellent. Excellent. Question 11. Can procedures qualified for category FP be employed for category SP and GP? Notation.
4.8.
Yep. And it says yes without further qualification. Question 12. Does a change in the number of electrodes require requalification?
I got 4.11 AI here, but it could be yes and no, couldn't it?
Well, I've got the same table, but I've gone B. Have a look at B for me, Ben. B and J, I think. So you've got, can you see that there, Ben?
Yeah, I got it now.
Yeah.
I just went with the runs required 25% more. If
Yeah.
you're going to do more runs, you're going to use more electrodes.
Correct. Yeah.
But if you keep it under that 25%,
Yes.
you wouldn't have to requalify.
Correct. All right. 13. What is the extent of testing required for SP and FP for a non-qualified butt weld? What do we got? Got a table?
4.7.1.
Yes. So what's the requirements on the for a non-qualified butt weld? So what are we looking at?
2 macro, 1 tensile,
Yeah.
2 side bends, a face or a root, 3 Sharpie,
Yep. Well
1
done.
comparison
Excellent.
hardness and 1 heat affected zone hardness.
Well done, Ben. Seems like you're all over this. Question 14. A bender has a crack in the heat affected zone and measures 2 mil. Does it comply?
Yeah, it's 4.7.6, no more than 3 mil.
Correct. Well done, Anthony. Well done, boys. I'm really happy with that. All right. Let's have a look at this WPQR and this WPS. So when you looked at your WPQR, there wasn't, what was missing out of there? Can somebody tell me? So you would have had your steel group number wasn't there. You probably didn't have any of for the joint configuration, you wouldn't have had your root face, root gap, and so forth. Your preheat temperature, also your heat input, and then the amount of non-destructive tests. So, and then the mechanical testing. So let's start off with the steel group number. What did you get?
I got 4 for the steel type.
4.
Boom. Excellent. Now for your joint configuration, what do you got there?
53.3. And that's what I was talking about with the design throat thickness before.
Yeah.
Is that
Yeah.
just 12 mil?
Correct. Yeah. So the design throat thickness. And what about the actual joint ID?
BC3.
Boom. Well done, Mark. Is there any preheat required?
I've got 0 as a weldability index A.
Correct. Well done. That is spot on. So, all right, for our first run, what was your kilojoules per millimeter on the first run?
0.597.
So would you round that in a situation like that, Ben, would you just round that off?
Yeah, I just took it to 3, but yeah, it could be 0.6. Yeah.
Yeah, okay. So 0.59, 0.6 is what we got to consider here. It's not going to be, each individual might do that, Ben. They might round it off or they might not. They might leave it as is, just drop the 7 and leave it 0.59 and whatever. So when we look at it overall in the big picture, that does not make any real difference, if you know what I mean. What about your second and third run? Or even your fourth run for that matter?
Second and third 0.866, and the fourth was 0.537.
Right. What about your cap?
Oh, sorry, that was a cap. Yeah.
That was the cap, yeah. So what we had was basically 0.59 or 0.6, if you wanted to go that way, 0.86, 0.86, 0.54 was the heat input. Just to give you an idea, guys, on that, the guys that are doing the Cert 10, in the standard, it stipulates where our percentage goes in the upper and lower. For the guys doing the Cert 10, they have a little bit more a difficult task than what you've had. What they do is they get an upper and lower in their heat input, and then they have to work back and determine where it sits in their volts and amps and travel speed from their heat input alone. So there's a lot more fiddling around in trying to calculate. In other words, what it's doing, it's relying on the supervisor's ability to be able to think of, you know, where that heat input sits in the upper and the lower, and now basically going back and working out, right, originally I had, you know, X amount of amps. I've got to work out where my lower end heat input is, and then try and work back and slowly work back down the amps till we get close to that heat input, if you know what I mean. So it's a little bit more difficult for them to do that. All right. Non-destructive tests, what have we got for there?
Michael. 100% visual.
Yeah, visual. And then for the mechanical, just a macro.
Got macro and hardness it requires for qualified joint and consumable.
But is the material joint and materials pre-qualified?
Yes, I found them both.
So do we need to do a hardness test?
No.
No.
Thought it was in 4.7.1.
I think you'll find that it won't require it.
In the heat affected zone, one test.
One test.
4.7.1.
Okay.
The note says if the preheat qualifies, you don't have to do the has hardness.
And that's where
we didn't have a preheat. That's also.
Yeah, we had no preheat. All right, so ambient temperature was the requirement on the preheat. So that's where that's what Mark said is what I've got written down here. Okay, right. So there's our WPQR. So now we have to develop our a WPS. So now what we're looking at is we're filling out the rest of the details. So we know our steel group numbers 4. We've already got our joint configurations. So what you now got to fill out is you're filling out the document. What you sometimes get in your assessment too, guys, is you'll sometimes get a WPS to look at, and then you have to work out what's missing from that WPS. All right. So I want you to make sure that when you're looking at this, that you're looking at the application of standards, the category, the qualification standards, the material, the grade, the product form, plate or whatever, the thickness, making sure that they're all there, your temperature, preheat temperature. And it's also important to know that your consumables must be written down there and so forth. So when we get down to our WPS information, we basically, we can see from our WPQR, we've got the actual welding process, we've got the position it's being done in, we've got our welding power source, we do have our electrode manipulation, so we were doing stringers, we do have our shielding nozzle diameter, which was 15 mil, we've got our interpass cleaning and so forth, all that information was there. So really all you were left to do is really now work on the upper and lower end of your welding parameters. So originally, let's start from run 1, and we'll start with our current. So our current was originally on our WPQR was 200 amps. So what I want to know now is I want to know the lower end of that welding parameter for the first run.
180.
180. Boom. So what's the top end now?
220.
Correct. All right. So let's just do the current first. All right. We'll go through all the current on each of the runs. So the second and third run, even the fourth run, What's your lower end on the second, third, and fourth run?
225,
And the upper end?
275,
Right, spot on. When we look at our cap, our lower end,
162,
upper end,
198.
boom. Well done, Jay. Spot on. All right, a voltage. So originally our volts were sitting at 24 volts from our WPQR. What's our lower end voltage?
22.3,
What's the upper?
25.7.
Oh, you're good. Oh, you're good. All right, let's do the next two, the 2 and 3 and 4th run. Lower end,
24.2,
upper end.
27.8.
Right, spot on. That's what I have. The cap.
22.3 and 25.7.
Hey, Jay, got it. Righto, travel speed. So originally our travel speed sat at 482 millimeters per minute. So our lower end will be on the first run.
409,
Yep.
and upper end will be 554.
Good. Second, third, and fourth run.
382 lower end and 513 upper hand.
Okay, and the cap.
409 to 554.
Good. Righto. Heat input. Hang on. Jay's answering all this. How's everybody going? Got similar calculations? All right.
Yeah, we've got all those. Yep.
If you're within, if Jay said, say 409, you said 410, there's not anything, that is not going to make any major influence on that. You know what I mean? So you do often find that there'll be a little slight variation and on how the calculations are, but these are exactly what I have. So, but what I'm getting at is if you were to round it off or whatever, it does not make any real major effect on the actual outcome. You know what I mean? So if
I rounded off the voltage. You don't need to do the points in the voltage, do you? Or should you do them?
Look,
I just rounded them off.
I mean,
Half a volt one way or the other is going to be a bit of a difference.
yeah, but
Yeah,
I mean, if you looked at 25.7 volts, could you honestly see an actual operator getting within 25.7 exactly?
Yeah, I put down that it's 26.
You know what I mean? So does that, say for instance, if we had 26 volts there, how much that heating would affect it? That I don't know, if it would have, affected that great deal, if you know what I mean. This being a multi-run overhead, what you tend to find, there's always that variation in the operator. He's not going to just go and bang that out. So in other words, the temperature will be slightly controlled a little bit more, if you know what I mean. So depending on the calibration of your machines as well, you've got to understand if your machine can actually get that, I mean, that's naturally where you want to go. But would he be in that upper end, if you know what I mean? Or is he going to be sitting in the middle? And that's why we have that upper and lower end where the operator will sit. And you probably find that in that upper end, it'd be very rare that the operator will maybe be sitting dead on that, if you know what I mean. He might be sitting back a bit and you'll find that's still hot enough and the heat input's fine. Second, third, and the fourth run heat input, what have we got there?
0.43 to 0.82.
And for the last one?
0.41 to...
So what I've got for mine is I've got for my second, third, and fourth, I've got in the lower end 0.63
to 1.2.
1.2. And then for my last cap, I've got 0.39 to 0.74 in the upper. Did anybody have that similar?
Yeah, I had the same as that.
I've got same.
Okay. So, but you know what? You're all within that sort of close range. So remembering that it is all dependent on the calibration of your machines if you're going to be exact. And remember that the operator will probably, if we're looking at, with this process, for instance, there, we're in that voltage range. me personally, I believe that the operator be very, I think it'd be hard to handle it right at that real top end, if you know what I mean, with this process, especially in the overhead position. So it is quite fluid with those sort of voltage range and that current. So
In the materials, Joe, in the materials there, what's the heat number?
Heat number, where we're looking there.
Under the steel group number.
Steel group number. Oh, I just haven't got anything there, to be honest with you.
Yeah, what is it, but what are they referring to?
That's
I
a
think,
heat number, isn't it?
That's heat sheet materials, isn't it? Or
yeah, I think it's more to do with your materials. So it is with materials, but the heat number's probably, when we're looking at the grade we're looking at, and it's only 350, Ben, it's not, you know what I mean? It's not a real, it's when you start looking into those quench and tempered and you're getting into those alloy type steels, then you might require that heat number on there. But it should be in the standard there, heat numbers for your materials.
They are from the manufacturing side.
They come from the manufacturer. So that'll be on your material certificates, Ben.
Yeah, on the certificates.
Yep. So if you get your material certificates come in, they should have the heat number on there, and then you just put that actually in that if you wanted to put that on there. But it's not probably one of those things that's super critical, if you know what I mean. It's not probably going to have any major outcome on the overall thing. When we're looking at it is we want to know the standard we're working to. We want to know the actual material type, that our joint configuration is compliant, the process that we're using, and then working out our volts, amps, travel speed, and our heat input, and then it's determining that for the rest. So remembering that too, that WPQR has already been sent off and been tested, so you'll know then if you're going to be compliant or not. So before you do develop your WPS. Well done, guys. Well done. All right. I'm definitely happy with the way you went with that. Now, okay, let's go through this standard now. Not many slides on this, guys. Really not, because really I'm just going to be repeating myself from standard to standard. So there's not much. There's just a few little variations in this because we now are looking at fatigue purposes. So now we're looking at areas that might be due to earthquakes and that sort of thing. That's where this fatigue loading side of it, they do mention seismic movement in materials because of earthquakes and so forth. So where you're looking at areas like New Zealand, for instance, they'd be looking at most of their steel structures in the towns that have suffered earthquakes, where they'd be looking at this sort of fatigue loading and that sort of thing, where this would be coming out. This is where the sort of standard they'd be using for that. So that's generally more or less, you know, and it does have a few little variations in here, but what you'll notice is it is set up basically exactly the same. When we look at, you know, when we're looking at section 1 and we're looking at scope in general, for instance, our MPA is still the same as what it is in 1554 part 1. So what you're going to see is it's almost duplicating everything that's in there from all the other ones that we've talked about and gone through. And that, I suppose, in a sense, is much better for you guys to navigate your way through, because if you get really familiar with 1554 part 1, the information that you're looking for now is almost identically in the same spot in, you know, in the other standards, but they've just got a little bit more specific information on that particular one. You'll see a variance in tomorrow when we do 1554 part 6, because it's mainly stainless. So there's a little bit more information on the stainless side of it if you're dealing with that. So that is quite a little bit more information in there in relation to all these other ones. If we look at 1554, we're looking at part 1, we're looking at our, you know, GP and SP. And as you can see, as we progress up a little bit, particularly in 4.5, quench and tempered, fatigue loading, so different types of materials, but everything is set up exactly the same. The tables are the same numbers. The they're almost on the same sort of page. So there's no real variance in here. So what you'll tend to find when you guys are doing your assessment, the main standard will be heavily from 1554 part 1, because that's the crux of all this. You know, that's where all most of the information is. So when you start looking these other particular standards that we're going through, well, those questions have to be more relevant to this standard. So what it means is it's now looking at the specific parts in the standard for that information, because everything else is the same. You with me? So when we're notating this one in particular, it'll be more on the fatigue part of it, where the information is on that fatigue part of it, because everything else is the same as the others that we've been going through. All right. So let's have a look at, so I've got my standard in front of me, so I'll flick through as we go through it. So we go to scope, and it's exactly the same setup. The only thing is the difference here in the scope, and I haven't got it mentioned here, but it says here the standard specifies requirements for the welding of steel structures made up of combinations of steel plate, sheet sections, including hollow sections and build-up sections, castings, forgings by the following processes. So that is exactly the same. But when you start reading through here, what you'll notice here, it now mentions the standard applies only. So this is underneath your yield strength of 500 MPa, and then it goes there. The standard applies specifically to the welding of steelwork in structures complying with same standards that we've been seeing, where the welded joints in these structures are governed by dynamic loading conditions. The standard applies only to those welded joints that comply with fatigue provisions to AS2214, where the stress range in the welded joint is greater than 80% of the permissible stress range of category B. All right, so there's a little bit of specific information there because it's now fatigue loading. It stipulates there, and the key thing there is the 80%. All right, so if I was going to give you a question on this particular standard, that would be something I'd be wanting you to know about the 80% of permissible stress range for category B of AS3990. All right, so it is referencing that standard. So if you wanted to know that sort of what category B was sitting on, you would have to reference that standard to find that information. And then it goes through there, or exceeds, and I do talk about it here in a minute, exceeds the stress range permitted in detail category 112 or AS 4100, 4100 or NZS 34. So what you're going to find, guys, is you can never have enough standards. There's always going to be ones that are referencing other ones that you need to go to. But I don't want you to go out and buy them. I mean, that's the company needs to do that. But you need to have access to them. That's what I'm getting at. All right, just to clarify the information that you need to be looking at it all the time. All right.
So if we get that kind of question in exam, Joe, we need to reference that standard as well, or
no, Jay, because we've already told you these are the standards that you only need. So the standards you only need are 1554 part 1, 4, 5, and 6. So the question has to be relevant to the standard. But what I'm saying is, when you get a question or something like that, the question might want you to write or say that you've got to reference AS3990 as well. You know what I mean? But you won't be needing to reference that standard. You'll just have to mention it, if you know what I mean, for further information reference. But you guys have got multiple choice questions. So basically what you'll have is you'll have 4 answers sitting in front of you. You'll go to the standard, and if you're in the right spot, it has to be exactly what the standard says. So there's not going to be any fluctuation here. It's whatever the standard says. So say, for instance, Jay, you get a question on, and it's wanting that 80% permissible stress range. So the question might say, what is the permissible stress range related to 1554 part 4? And then they might have 70%, 60%, 80%, or 100%. All right. Now, for you guys, you don't have to notate where you found that information. Hence why I'm getting you to do that for me, because I want to know for sure that you're actually sitting in the right part of the standard where that information is. So I believe that's really helpful for you guys. Want to know where specific information sits in each topic. You with me? So by notes, by giving me the notation, I now go, bang, he's in that right spot. He's referenced the right table. Because sometimes you can find the same sort of information in a different spot. You know what I mean? So you guys won't have to reference any scopes or any tables or anything like that. You'll just have to pick the answer. So going back to that question originally, Jay, all you'll do is go, boom, 80%, mark 80%. You know what I mean? You won't have to say 80% 1.1 scope. You know what I mean? You'll just look in the standard and you'll go, right, they're talking about permissible stress range or whatever. The welded joint is greater than, and the percentage, boom, you look through the standard where that information is, which you know where it is because it's sitting in scope 1.1. And you go, right, where's the figures there? They got 70, 60, 80, and 100. Oh, well, 80, boom, there it is in the standard. That's what I'm getting at. They have to be, as you see it in here. You can't go, they can't put 85% or 75%. It has to say what it's in the standard. You with me? So if you are in the right spot and you've got those 4 multiple choice answers to look through, all you're looking for is one of those correct ones from the standard. You know what I mean? So you just got to be in the right spot to know where it is and you'll find it. Does that make sense? Yep.
Yes, thanks.
No worries. So when we start going through, and when we're looking at scope, and like I said, it's exactly the same as all the other standards, right? And it talks about our processes, and they're exactly the same MPA, minimum yield strength in this one as well. So these are particularly the ones that are, they're talking about in this particular standard. It does reference ones in there that we don't, we're excluding. And it's the same it's exactly the same as all the ones we've been going through. There's no different at all. And that's why it's good to, I believe, to go through these first, like do your 2214 first, because it gives you an understanding on how these are all sitting. But for you guys in particular, even though you've got, 4 or 5 standards, 4 standards, 5 standards to work through, they're all formatted the same. They're almost identical in tables, identical in nearly in the same pages. So it's really easy to navigate your way around once you know that. But you'll probably find in your work, the 1554 part 1 is probably going to be the most common one that you might be working to, unless you're doing some specialized work where you're going to be referencing these other standards. But they're still set out the same. Whereas the Cert 10 guys, they're all over the shop. Like the information they've got to find is you can go into one standard. Say for instance, they're in 1210 and you want to find out the amount of destructive testing that's required on a class 2 pressure vessel. They won't find it in 1210. They'll find it in 3992 because that's all about testing and qualification and all that. The information's in there. So they could get questions where that's referencing 1210, but the answer's in 3992. You know what I mean? So they've got to be able to fluctuate and flick through individual standards because it's more specific on information. Whereas we have a lot of information in the one standard. It's all formatted the same. The table's the same. Everything's structured the same. But when we get into the individual one, like we're talking about today, it's now specific on fatigue purposes. So then you find that extra little bit of information in there on that particular part that you're talking about. All right. So we can see there that our welding processes are the same. And then we start going through. And when we look through the standard, our 1.2, exclusions, 1.3 innovation, all that is set out and is exactly the same word for word as 1554 part 1. But when we come to our weld categories, that's where we get a little bit of a difference now. Because now what we've got this standard specifies requirements for fatigue purpose, weld category. So what you're going to notice now is when you go to that table 6.2 or 6.1.1 or whatever, naturally our our acceptability on certain things is now a lot different. Mark, what are you ripping up, Mark? You had enough, mate. Throwing it away. Is that it? Done? So what you're going to find now is we've got a little bit more information on fatigue purposes. So when we go into those tables, we've now got that extra well category sitting there in that table. And now what was permissible, say, for SP may not necessarily be permissible for fatigue purposes. So then we start our things are starting to change dramatically as the quality or the purpose or the load structure and all this lot changes. Hence, so do what's permissible and what's not. So when we're looking at this one, it's talking about high levels of dynamic loading where stress ranges exceed, and then it's detailed category 112, and then it's referencing 4100 or 34041, or where we exceed 80% of the permissible stress range, category B, and then AS2214. So it's mentioned it again in there, and it mentions category 112 again. So it's mentioned a few times, as you'll notice, and so as the standards are. But if you're coming to well categories, naturally you're going to look for that information. And if you notice there, that is the only thing it's talking about in this particular. It's not mentioning GP, it's not mentioning SP, because they're referencing 1554 part 1. It's now referencing FP. So when you start looking at tables, and if I look at table 6, for instance, and 6.2, let's have a look. What you'll notice there, 6.1.2, it's now specifically only on FP. We're not bringing in, we're not trying to confuse you with your GP or SP and making it more difficult to look at. It's just now specifically on fatigue purposes only. So cracks, not allowed. Lack of fusion, not allowed. Undercut, not allowed. Shrinkage grooves, not allowed. Root concavity, not allowed. So as you can see here, we're in a much, much more higher level of compliance in relation to our imperfection types, all right? And then our tolerances, our reinforcements and those sort of things, they're a lot tighter now, all right? Okay. So when we start going through there, we've got our, well categories, management quality, basic requirements, safety. That's more or less the same. We go on to the next page, and then we hit our parent metal. So naturally, some of these grades might be slightly different. So parent material to be welded shall be of a grade with a specified minimum. So we are talking about the minimum 500 MPa, all right? But it's selected in accordance to Appendix B. So Appendix B naturally is all sitting at the back of the standard, and you would reference that and see. Let's have a look and see what Appendix B says. Okay, Appendix A, Appendix B, brittle fracture. So it's now talking about notch, ductile range method, design, service temperatures, and so forth. Material selections there, limitations, and so forth. So then we start looking at service temperatures, and hence why. And while I'm there now, I'll just explain to you about this LOD map, for instance. What we've got to consider is when we are building certain types of structures, we've got to be aware of the lowest temperature in that part of the country. All right. So you'll naturally see that. And we've got to make sure that when we are selecting a material, that it's going to be the right material designed for that lowest temperature range where it's going to be sitting in the country. But what I can tell you, though, is whenever you build a bridge and it's going over a water, all right, when we're going over water, your service temperature has to be an extra -5 added to what you see here, because they believe that as a bridge going over water is in the winter months, say for instance in Tasmania, that temperature will be a lot colder over the water than it would be on land. So hence they allow an extra 5 degrees. You always put an extra -5 degrees on top of what the actual service temperature says. So if we were to look at our steel type here on that table B1 on page 72, for instance, you'll see the temperature for your material thicknesses and your, thanks, Nina, and your material types. So if you were to see something like that and you were building a bridge out of something similar to that sort of material, and it said -10 and you're going over water, it now becomes, it has to be -15. So then you would have to check your steel type to see if that surface temperature goes that low. You with me? So, and one of the main reasons I know that is because when I was doing this, like you guys are now, that was a question I had. Okay. But we were told during the training that, and it was when it came to this part of the training is the standards, the inspector that was delivering it said, always be aware when you're doing if you're involved in a bridge and it's going over water, there's always an extra -5 degrees added onto that minus temperature to allow for that sort of colder, because it's colder over water than it is over land. So it's an extra -5 degrees. And when you look at your log map and you see the temperatures there, that's your lowest ambient, that's your lowest temperature they look at in winter. All right. So what it's doing is giving you an idea of where your temperatures are sitting in relation to, you know, the colder months. All right. So that's what we've got to consider when we're looking at any sort of structure that might be going over water or something like that. We've got to allow for that and make sure that we've got that material can handle that sort of temperature. Does that make sense? Good. I thought while I was there, I'll just explain that. So if you've often wondered what that meant, so that's for you. If you are building some sort of structure that is going to be in lower temperatures, you've just got to make sure when you're looking at your material thicknesses, and particularly if it's going over water, that you've just got to add that extra -5 degrees on top of it. All right. And it is in the standards somewhere, and I just can't remember where it is, but it's there. Okay. And I will find it and I will point it out to you. All right. Okay. Back to where we were. So note, any steel type from any standards may be welded to any other steel type from any standard listed above, provided the requirements of the standards are met from each of these steels. So you can reference, these standards have a lot of material stuff in them. So you can reference this and it's still, you know, okay to use. So we have a range of materials to choose from in the standards that we're working with. But if you're looking for something a little bit more, maybe exotic or a little bit more different, you might find it in these other standards there. All right. If you want clarification on it and so forth. If you've got a material that you can't find in here or in 1554 and you reference this, that should tell you its weldability number, its carbon equivalent, and give you all that information as well that you require to work out your heat inputs and so forth, and any preheat requirements. All right. So you will probably, as time goes on, you may have to have an extra couple of standards there with your material types to reference. It just depends on what type of work you guys do, and you know, it's if you can get all your information out of the 1554 part 1, 4, 5, and 6, well, so be it. You know what I mean? You don't naturally have to reference these. So when you start going outside it. All right. Okay, let's have a squizzy. So I've now just basically, on the next slide, I've talked about parent metal. And as you can see, it's very similar to, or if not the same as 1554 part 1, and a little bit different with your parent material in 1554 part 4 because of the quench and tempered, but everything else is still sitting in the same, talking about material backing, welding consumables, flux, shielding gas. It's all the same in the same sort of spot. So when we turn over, now we hit our section 3, and we're talking about our welded connections. That's basically all. It's identical again. Design thread thickness and so forth. So I'll just flick to this next slide. Come on, move. All right. So what we've got here, and this is exactly the same as well, is we've got the size of fillet weld shall be the leg length as defined So if you wanted to be a little bit more specific, I suppose, wanted a little bit more information on leg lengths and so forth, but there's enough information in here. In all the standards that we've been working through, there's enough information there where I don't think you'd need to reference that one at all, but it's defined in there if you were, you know, but we all know what our leg length is. So we shouldn't have to sort of go to that. And then when we look at it there, it says there, the preferred sizes of fillet wells less than 15 mil, and then it gives you 2, 3, 4, 5, 6, 8, 10, and 12. Then it says where there's a root gap and size, they shall be given by lengths of legs of the inscribed triangle, reduced by the amount shown in table E3. E3 is now towards the back of the standard, and Appendix E is at the back of the standard. So when you want to be specific on fillet wells in particular, and then it starts going through, you know, if you've got a fillet well and your fillet well there, what should be left there, like 1 millimeter, I think it is, and so forth. It gives you more specific information on how your fillet well should be in relation to your fillet well configuration, all right, and how it sits. And you can reference that and go back and you can get the information there. So if we look at table E3, which is, like I said, Appendix E, what Appendix E is just giving you the joint identification. In other words, the notation of it. So B for butt, C for corner. So that's what Appendix E is giving you there. Okay. But when we start looking at the tables and we're looking at E3, table E3, and we go through there, naturally it goes through E1 and so forth. Table E3. So what you can do, guys, if you wanted to, when you're doing your WPQR and your WPS, you could actually reference this joint identification here, F1, F2, F3, as part of your joint identification on there if you're doing a fillet, if you wanted to. All right. So you've got all the information sitting there for you. All right. And then you've got all the other tables to reference for the other types of joints. But that's where you can get that information from. Okay. And also too, when you look at on when we start looking at those minimum leg lengths, and we're referencing table 3.3.5 on page 15, for instance, and I'll just go to that. When it says there, the minimum size of fillet wells, including the first run of a multi-run fillet weld, other than fillet wells used to reinforce a butt weld, shall be given, and we reference the table, except that the size of the weld need not exceed the thickness of the thinner part joining or being joined. And then you can reference clause 5.3 and it mentions that there. But when we look at our table 3.3.5, which I'll go to there, we can see there when we start looking at thicknesses and thickest part, it's just referencing there, and then you know what your minimum size of fillet is, leg length is required. So it's giving you the information there to know what your minimum size should be. You can go over, but also too, when you look on page 14 alongside that design throat thickness thing there, okay, and then when we look at that now, it is more on your fatigue purpose type now, and it does mention blending in and so forth. All right, so it's all about fatigue load stress, about that stress going through the joint and so forth. All right, but that's still that fillet weld size is still the same as what we've seen in the other tables. All right, in the other standards. All right, okay. Procedure qualification of fillet wells for plate and pipe. We've mentioned and talked about that there. There's no difference in here. So we're in section 4, qualification of procedure and personnel. We now, as supervisors, as you know, what we want to do, we need to qualify guys to our weld procedures. So whatever procedure we develop, if we can get multiple positions out of it, that's what we need to do. Like I said, vertical will always be a sit alone weld procedure, and that's all because of the heat input that we're putting in, because naturally that we're in a vertical position, we're going much slower, so our heat input is is going to be a lot higher. So hence they always tend to run that basically on a sit alone weld procedure. If you have a look at, if we looked at processes like electro slag and electro gas, where we're doing open square butts, the amount of heat input that's going in that material is so high because it's a big vertical up and there's a lot of heat going in. So what you'll find when that joint's being completed in that vertical position, that actual shell will probably be put in a furnace and be normalized because of the amount of heat input that we put in there from that vertical position. All right. So, and even if it was a lower grade steel, we still would have some issues in our heat affected zones where our grain structures probably changed quite dramatically because of the amount of heat that's gone in there. So hence those sort of processes in that position will probably need some sort of normalizing to get it back to a sort of a good structure. All right. Right. So when we're looking at there, we always want to see if we can, if we are doing some welder quals, what we're looking at is when we're doing fillets, for instance, what you always want to do is have your fillet plate set up, have one side a single run, other side multi-run. All right. So what they'll do, you'll say you want that one done and you want that one done. You'll get two separate reports, of course, but it'll be out of the one sample. So you'll get the picture of that, naturally macroed, saying the single run complies, and then another sheet with the multi-run on there. So now your guy is qualified. And naturally, if you start qualifying in you know, the overhead position, we're now qualifying in the downhand and the flat position for fillets and so forth. So it's just depending on where your operators, what sort of position you're putting them in. All right. And if it requires them to, you know, do some out of position work. If you can rotate it, it's all fillets and flats, well, that's fine. But if your operators are getting in positions where we're now looking at overheads and stuff like that, then hence you need to qualify them for that. All right, guys, I'm looking at Mark. He's always telling me, I can always tell by Mark when he's due for a little break. And I think he's due now. Yep, he's giving me the thumbs up. All right, guys, have a quick break and we'll finish this one. Mark, you all good now, mate? Recharge, ready to finish it off? You know what, guys? You've only got me tomorrow and that's it. We're done and dusted. So it's come around fairly quick in the end. A bit slow at the beginning, but it's certainly ramped up towards the back end of this course where it's just gone a lot quicker, I think. So only one more standard to go through tomorrow, but I'm really happy where you guys are sitting, you know. I think you're going to do really well with this. All right. Okay. So we were talking about, you know, procedure qualification. You're always going to try and qualify your guys for multiple positions if you can on, you know, a couple of WPSs. You don't want multiple WPSs around the workshop sort of thing. So you want to try and qualify them into as many positions as you can. And also, you know, if you are only just doing downhand fillets and so forth, well, that's all you do. I mean, if you can rotate the job, it's even better. But some of the stuff that you might come across, you might be welding some out of position stuff. All right. Okay. And that's what I was talking about there. Where a test piece requires procedure qualification in more than one position, the test piece qualifies the welding procedures for those positions, providing macro is taken from each position to be qualified. This can be achieved by welding pipe test on a 5G or a 6G position. So we're looking at a 5G, which is a fixed position, which is horizontal, naturally 6G, 45-degree angle, naturally deemed as the most toughest position to be welding in. And if your guy can qualify in that position, there's no position you can't do. So, and on pipe, where that angle is constantly changing depending on the size of the diameter of the pipe, that will tell you what sort of an operator you're dealing with or what you got. All right, so it's you as a supervisor. This is part of your role now. It will be meaning, you know, how can I qualify my guys for multiple positions and so forth. and then it's, you know, you're saving money for the company as well. All right. And then what we got there, we'll start going through the table. We've got there range of for welder approval according to welding position. So you got your plates, your pipes, butt welds, fillet welds, and so forth. So, I mean, that's, you know, it's what you're doing, butt welds and fillet welds. So they're going to be the most common joints that you'll be dealing with. So maybe you'll have you know, a couple of fillet WPSs and a couple of butt WPSs, and that's all you'll require if you've done them in an overhead position or something, and you're covered, whether it's plate or pipe. Now, when we're looking in section 4, hang on, I'll just click on to the next one. What I want you to be aware of too is make sure that you do read these notes. All right, so I want you to make sure that you do read the notes on these, because there's always some information that you need to sometimes reference, and it's important that you do reference them. And if we have a look here, look at this one here. The letters on the table refer to the welding positions as defined in Appendix E. So you can actually go to Appendix E, and if you're unsure of what those abbreviations are, it'll have it written in there, except for the vertical welding direction, D for down or U for up. So vertical down, vertical up. All right, so they reference it in there. And then it also says there, pipe rotating axis, horizontal welds, vertical, pipes fixed axis, vertical weld, horizontal, vertical, overhead, or an approved position, which is covered by other related tests. So use your tables, work out what's best suited for your business, and you will save not only money, but also you'll qualify you guys in multiple positions that will cover them for, you know, X amount of time. All right, providing they stay with that same process and so forth, they'll be fine. All right. When we're looking at those tables there, you got table 4.1.2.2b, range of qualification for welding consumables. Now it's mainly talking about your flux core wires and your TIG wire and your solid wire. Now, what you can see there with your gas metal arc wire, metal core is covered for, you know, your solid wire. If you are going to qualify, guys, 9606, be aware that in that standard there, they reference F1, F2, those types of things in there. So get yourself familiar. I would start to get yourself familiar with that 9606 standard qualification of your welders as well, because that seems to be the standard that a lot of companies are going to these days as well. So I'd be definitely putting one at that standard. I'll be getting that one and keeping that with you and getting your head around that one. With the new AS1796 standard, it's now going to incorporate 9606 in there. So there's going to be mention in that standard for 9606. The plate sizes for the testing in AS1796 are also the same, are going to be applicable to 9606 as well. So they brought them in line with each other to help it a lot easier, I think, for companies when you are qualifying to 9606 and AS1796 as well. So if you're looking down that pathway, make sure that you get at least those two standards as well. All right, that will help you in what you're doing and how you're going to test you guys as well. All right. Now we're into section 5, which is workmanship. It's no different, like I said, to the previous standards that we've been working through. It still does mention the same sort of thing with our thermal cutting. Surfaces to be incorporated in a weld shall not have a surface roughness greater than class 3. And what I'll do next week, I've got one of them, and I'll bring them down and I'll show you what a class 3 looks like to give you an idea. All right, what it is. Class 1, 2, and 3, they're a replica, they're plastic, of an actual thermal cutting, and you'll be able to see the quality of 1, 2, and 3. All right, and it'll give you a bit of an idea what they're looking at when they're looking at a class 3. Surface not incorporated in a weld shall comply, and it referenced in there. And also Tech Note 5 has a lot of information there on your thermal cutting and so forth. All right. For flame cutting surface being incorporated into a weld, it is considered good practice to lightly grind the cut faces to remove carbide surface layer. It's considered good practice. Whether your operators will do that, I don't know. But I know for me personally, if there was anything that was oxycut, I was never a fan to weld straight over oxycut. I'd always cleaned it up, you know, in one form or another, just to make sure I've got none of that carbide surface layer sitting there. All right. Preheating and interrun control, because when we can start going through this is, it does mention misalignment in here on page 44. So linear misalignment, unless otherwise specified, the correct position and for when the plate center line coincides and so forth, angular misalignment. So there is mention there, and there's a big figure 5.2.2, and then it's got a table of allowable joint tolerances, which is something you need to know. So know where that is sitting in there. Then your preheating and interrun control, which we're talking about now. And then it starts talking about your carbon equivalent and naturally your arc energy and doing the calculations there. So it's the same format there. It's giving you the same calculation as the previous standards as well. So when we're looking at control of preheating and interrun temperature is required for certain combinations of steel grade, material thickness and welding condition. Minimum preheating temperature related to the arc energy input may be determined in accordance to clause 5.3.4. So let's have a look at 5.3.4. And then it just says there, preheating and minimum interrun temperature shall be determined from tables 5.3.4 and 5.3.4b. So A and B, and then it's got figures there in accordance to the following method. Select or calculate the weldability group number using either the following methods. So how we worked out our preheating temperature, that's what they want you to go through. Or for a steel, a standard steel of known specification, select the weldability group number from that table as previous standards and so forth, working, and maybe you might have to work carbon equivalent out. But you know now how to determine that, how to get that information and how to work that out. So naturally, those sort of things will come, you know how to do that now. So that should be pretty easy, easy to handle, should we say. You will probably get, I think you will get the question where you will have to determine that, like do the calcs on it. I mean, it's a big part of the supervisor's role. So really make sure that you understand, you know, working out your combined joint thickness and your weldability index, getting your group number, and then determine your preheat. Because I do believe that there will be a question on that, you know, for you to do. They might have it all calculated there. You just have to, what they'll have is they'll have the answer there, but you'll have to do the calcs to work out which one it is. You know what I mean? So I would definitely certainly look at that. Now, the only thing that worries me a little bit is if it's very hard to be very specific on if they give you a question where they've actually got the actual preheat there, because it's so fine on the actual chart. So I'm hoping they put approximately, you know, 75 degrees or whatever. But I look, me personally, if you got a question on that and you had to determine your preheat, and say, for instance, their answer was 75 degrees and you put 73 or 76, I would still, me personally, I'd still mark that right, because you're within that range. If you were right way out, then naturally no. But you will probably get a question where you'll have to do that sort of calculation. All right, I do believe, because it's a big part of working out your preheat, and it's all part of your WPSs and your WPQRs and all that sort of thing. So I do believe that it'll be a question that they might throw at you. All right. Need for preheating. Where the metal temperature is below the preheating temperature determined from clause 5.3.4. So when we looked at that there, 5.3.4. a metal being welded and the arc energy employed, the metal shall be preheated to the required temperature and maintained at that temperature while welding is in progress. But when we look at, and that's coming from clause 5.3.4, but when we look at clause 5.3.5, now we've got our inter-run temperature, which is important if you're doing big multi-run fillets, where we've got to manage that inter-run temperature. So it then becomes sort of more on your steel type. So for welded structures, subject to seismic loadings, so where seismic resisting steel, so steel groups 2S and 5S. So reference table 4.61b, and it says there, specify the maximum inter-run temperature shall be 300 degrees C unless the weld procedure is qualified at a higher inter-run temperature, in which the case a higher temperature shall prevail. So if we do have an inter-run temperature that's been stipulated on our weld procedure and it's higher than 300 degrees, hence we have to stick with that. But if we don't, we're not supposed to exceed 300 degrees C. All right. So when we're looking at that, it goes through there. It's got our tack welds in there again. Same information on that tack welds as what it has been in previous standards. So there's no variation in there. Welding under adverse weather conditions is still exactly the same. Weld depth and weld ratio, still the same. Control of distortion and residual stress, still the same. Okay. Back gouging and repair of defects welds. Grinding, which I think I've got here. Grinding shall comply with the following requirements. The ground area shall be blended smoothly into the surrounding surface without abrupt changes in contour. So that's basically the same. All right. So that's the same information that we've seen in 1554 part 1. There's no change in there at all. Talks about our stops and starts, our temporary attachments, our arc strikes is still mentions there. Cleaning of finished welds, dressing of butt welds. You'll find that it's all the same. Quality of welds, or you can see there on section 6, methods of inspection and permissible levels of imperfections. Welds shall be inspected according to clause 7.3, 7.4, radiographic ultrasonic, permissible imperfections, and now it references our tables. So when we look at weld defects, so now we're going to reference table 6.1.1 or 6.1.2. Shall be, and the word, remember we said that shall is mandatory, be classed as defects, however, where it can be demonstrated by the use of fracture mechanics or other suitable methods of assessment that the defects will not be injurious or to the performance of the structure. Such defects do not need to be repaired or rewelded, provided any such defect is alternate and is acceptable to both the principal and the fabricator. So now you can reference Appendix D, item T. So let's have a look at that and see what that says. So when we go into Appendix D, basically all it's doing there is referencing matters of resolution. And then if you look at Appendix D, item T, correction or faulty defective welds and cost of well repairs are associated with NDE, and it just references the clauses to go to. So then you go back to those clauses and see what it says there. But it does say there, if you believe that the defect is not going to be sort of affect the overall outcome, providing that you speak to the principal and the fabricator and they're all on the same page, it may not require any repair. So it can be depending on what type of repair. Naturally, if it's a defect that's, now we're looking at into the tables and it's not compliant, well, naturally we are starting to look at repairing it. So repaired welds shall be re-inspected at the same level as the original specified. So we're now looking at, you know, doing that repair completely. All right. So and then when we look at here, suggested extent of non-destructive examination. So what you're seeing now is specifically for fatigue purposes only in this table. So what you can see in now is your 100% for your visual, mag particle 100%, and then other between 50 and 100%. So we then start looking at those. As you can see, it's got note 4, note 5, and note 6. So if we go to table 7.4, and we're now talking about inspection. So that's still the same part, section 7 in the other standards is still inspection. And it basically has got the same sort of thing, the qualification of inspectors and so forth. But when we start looking at suggested extent of non-destructive examination for fatigue purposes, then it goes down there and it says there, visual, we'll see note 4, visual means of NDE implies that the 2 following levels of examination, visual scanning to determine that all wells called for on the drawings are included and to detect gross defects, visual examination of percentage of all wells to determine whether required well quality and see table 6.1.1 has been achieved. We then look at mag particle note 5. The use of mag particle is unusual except for supplementary inspection after visual inspection for the types of structures and applications on which the standard is intended, and their use is usually restricted to repairs, and it's related to that. And then when we look at note 6, for plates with thicknesses of not less than 20 mil, a portion of each multi-pass butt weld shall be examined ultrasonically to determine whether there are any transverse cracks within the weld metal. So it's now stipulating about a plate thickness there in relation to what you can do there. All right. And that, my friends, is basically that standard in a nutshell. Okay. So that's covered that one all now. And I knew it wouldn't take too long because really it's just going over the same information that we've got in this standard is referenced again in all the other previous ones as well. So what we've got now is we've got little different tables in relation to fatigue purposes only. So our defects are only talking about fatigue purposes. Our NDT is more fatigue purposes. But, you know, we know that because that's what this standard is talking about. So we don't have the clutter of our GP and SP in here. It's now specifically on FP, but all the rest of it is identical to what you've been going through. So if you, when you start going through, and let's break it up into an assessment type scenario, when they want you to reference this standard, what we've gone through today so far, now we're more than likely be looking at tables and stuff like that because it's more referencing fatigue purposes. You with me? Like what's allowed for our defects, what's allowed for our NDT for FP, because everything else is the same. It's the same. It's repeating itself from standard to standard, the same sort of information. And there's no doubt in my mind that when you've been going through these, you're going, well, that's the same as that one. That's the same as 1554 part 1. So you're already knowing now where the information is starting to sit. All right. So when you get questions on this, you're going to find it'll be more specific to tables and so forth for that sort of information, because the rest is all the same. You with me? So you know your majority of questions heavily will be 1554 part 1, and then they'll spread the rest of them between the rest of the standards, because that'll be the one you'll be working from the most probably. All right. Is there any questions, guys?
I've got a question, Joe. So when the question will be in the exam, it will be, they obviously won't specify where the question came from, but they're gonna just give us sort of a hint that question is from 1554 part 1, and if the question's from part 5, they say like fatigue loading kind of hint. Is that correct? Or
so what I want you to look at is, first and foremost, when you start your assessment, they'll tell you what standard they want you to reference from. All right. So your first, let's say, is 1554 part 1. All right. So you've got 30 questions or 40 questions on that standard. So what I want you to be aware of, and I think this is a key part to help you guys in particular. What I do when I look at a question to know where I need to be in the standard. So I'm looking for specific wording that's relevant to that topic or that section. All right. So if they say something about extended or something to do with inspection, it's in section 7, or if it's to do with welder quals or WPSs, we're in section 4, those sort of things. So look for words that are specific to a section, and then you'll be able to go straight to it. So what I want you to do is read the question and think of, when you read that question, look at it and see, all right, what are they asking for here? What does it look? And then look at the answers. And then you'll determine, right, that's to do with material, or that's to do with inspection, that's to do with testing and so forth. And you'll be able to go straight to that section straight away. So they can't sort of, dilly-dally around there. If they want you to know, this is standard based. So what they'll do, the question has to be related to a section, and it's up to you to interpret that question to go to that section and be able to find the answer. So what I've always done, and I always say to guys, look for specific wording that tells you where you should be looking. Is it talking about NDE? Is it talking about WPSs? Is it talking about welder quals? Is it talking about materials? Those sort of things, and that then you'll be able to hit that. You'll go to it real quick. Hence why I want you to notate the standard, because by notating the standard on where your tables are and where certain information is, you'll be able to get to it really, really quick. So particularly tables, if there's a question on what's an acceptable allowance for undercut for SP, you're going to go straight to that table. Straight away, we're talking about imperfections. It's specific on a well category. Boom, that's where my information is. All right. So that's the sort of thing, Jay, you'll get. So when you're looking at your question, make sure you look for specific wording that will help you know where it's sitting in the standard. So if you know what your workmanship's all about, and remembering too that these are all set up the same. So if it's worded about workmanship, you'll know where to go. If it's, like I said, if it's about supervision and inspection, it'll be section 7, because that's where it references it, and so forth. Any of your weld imperfections, we know it's a go-to table where we're going to find and determine the information in that. What our allowances are and what's not. Okay, so I think you'll go well. I think I really got a good feeling with you guys that you'll all do extremely well with this, because you've handled those. If you have a look at the questions that I've given you, in all seriousness, I've asked you to notate that for me, so I've got an idea where you're sitting in relation to the standard. So what you've done is, not only have you given me the answer, but you've given me the notation, which tells me you were in the right area. All right. So you're not, what I don't want you to do is to get to your assessment day and then you open up the standard, okay, and then you go to your contents, you've read the question, and you start looking through the contents and going, well, is that on welded connections? Is it, you know what I mean? I want you to be able to assess that question straight off the top and go, right, it's all about welded connections. Boom, section 3, bang, and go straight to it. You with me? But have it notated so you know. Even if you went section 1, like that. But what I tend to do for me personally, I always, when I've got a particular section that it's a go-to, there's always going to be certain information that's always a go-to to get to information. So naturally, I'll either highlight it in the standard with a highlighter pen, or I'll notate it and I'll make it specific. And I've notated it specifically to a clause. So that's the way I do it. And what it does, it allows me to get there quick. When you're actually in the industry and you're actually not having a time constraint in when you've got to find the information, it's much easier to sit back and really sort of study it and go through it a little bit better. But in an assessment situation and you've got a time constraint, it means that you have to get there quick, because you can't dilly-dally around on a question for too long, because the longer you hang around a certain question, the less time you have to finish it off. So the less questions you answer, unfortunately, that then sets you up to bring in that lower end that you might not pass, sort of thing. So you need to be able to answer as many questions as you can. And so I would look at, you know, if you're looking at 100 questions and you've got 2 hours to do it in, you know, you're looking at probably, you know, a couple of minutes per question. So you can't, what I'm saying is don't dilly-dally on a question. All right. What I do know from previous training with other guys and that sometimes they've gone in through half a dozen questions or more, and then all of a sudden they found where that other answer was. You with me? And then they've come back and done that, which you still can do. You can go back and still do it if you haven't done it. But what I don't want you to do is just hang around too long on any particular question. All right. Any questions, guys? No.
Joe, do we need technical notes for the exam?
No. Just your standards.
Oh.
Just the standards. Is any of you guys referencing your standards from the computer? Or you've got paper ones? All right, a tip for you, Dorawinda. What I would do for you, if you are referencing your standards and you're not able to notate them, if you look when you open up the standard, you can search, okay? And what it does, it'll highlight specific words. So if you're going to do that to help you, what I would do is when you read the question, if there's a specific word that stands out, type that word in and search it. And then that will bring you up to that particular, where that wording is. And then you'll be able to reference that and work your way through. That's your only way you can do that. Otherwise, you're going to be scrolling. You with me? So for you, if you are using your standards as on your desktop or on a screen, you need to search the words, because otherwise you'll just flick through. You know, even with being on a computer, even if you know what section you've got to be in, it's still, you've got to get there. You know what I mean?
Yeah.
Whereas when it's notated, you look at your notate and you flick it open and you're there instantly. All right. So it will affect your time constraint a little bit. So what you need to do is type in that word and search it, and that will give you where it be. And it could be in, that wording could come in multiple pages.
Yeah, no.
But if you understand where you need to be in what section it is, it'll even be better for you. In other words, if you get a certain word, you type it in and it comes up, there's 7 notations. Yeah, I'll hang around, Ron. You might go to, if you know where it is, what section it's in, just go straight to that section and you'll see the word highlighted in blue, usually in blue, and then you'll be able to go to it.
Yeah, thanks, Joe.
All right. So that's a little bit awkward for you, Dorawinda, when you're looking at, you haven't got it notated like the rest of the boys, that's all.
Yeah,
But
Joe,
you'll be fine.
I'm trying to use combination of both. Like,
Yeah.
if I'm missing something in the, I have got the printouts.
Yeah.
But I'm missing something in here, then I will go into the search bar and search over there the particular word.
But search the word.
Yeah.
It's the word that's going to take you to the spot.
Yeah.
The wording is very specific in these standards, if you know what I mean. So, and if you know, no worries, Ben. If you know the situation where your sections are, you'll find the answer. All right. Good. Excellent, boys. All right. All right, Ryan, I'll hang around for you, my friend. The rest of you guys, I will catch you tomorrow. Have you guys done all the review questions now? Yeah, have you gone through this particular one? We can go through this topic, like this standard tomorrow, but see if you can knock over the other questions for part 6, and then we can do them as well, and then I know we're okay. All right. Good. Okay. No worries.
Thanks, Joe.
No worries. Thanks, guys.
Thanks, Joe.
Great.
How you going, Joe?
Ryan, how you going, my friend?
Yeah, not too bad, mate. Not too bad.
Good.
Hey, I'm just probably a little bit behind the group at the moment.
Yep.
Just with some of the things. My review questions, most of them I'm getting right. Just a couple I've got to tweak. I'm okay with that.
Yep.
What I've just because I was a bit behind with resitting my exam.
Yeah.
Just missed doing the well procedure qualification records.
Oh, okay. Yeah.
So, just a quick question with that.
Yep.
So we're going through filling out all our thickness. Stop there.
So what you've got first and foremost is your WPQR. So what I wanted you to do with that WPQR is just go through that and because most of it is filled out, all right, except you need to work out what the steel group number is on that.
Yep, right.
And also you've got to fill out the details for the joint configuration.
Yep.
So
right.
you need to go into the table,
Yep.
find that joint and get that information there or fill it out. Well, I mean, it's got it there. It's got the included angle is 50
Yep.
degrees and it's got the root face and root gap and it's got the material thickness. So that's okay. But what you need to do is you've got to find that joint, that type of joint in the table
Yep.
and then put it in the joint ID table number.
Yeah, right. Yep.
Okay, so your steel group number is one of them that you had to get.
Yep.
You had to get the joint configuration or the joint ID part of it. This is on the WPQR.
Yeah, on the PQR. Yeah.
And then you've got to look at whether does it need preheat.
Yep.
So it's now based on your material thickness, your material type. You can look at your heat input, your amps, and you can work out its weldability. You've got the steel group number. You can determine whether you need preheat that by going through you're looking at your combined thickness and working all that out and then double checking to see if it needs it or not.
Right, yeah.
And so forth. And then what you had to do is determine your heat input. So volts, amps, travel speed, do the calculations on that to work out run 1, 2, 3, 4, and your cap,
Yep.
right?
Yeah.
And then what we've got to look at is then we're looking at our non-destructive tests and our mechanical tests.
Mhm.
So by using all that information, reference the standard to see, yes, I do need visual, I don't need dye pen, I don't need make particle, I don't need UT.
Yep.
And then when we look at a mechanical test, we should be able to have reference that it's a pre-qualified material, it's a pre-qualified joint, it's a pre-qualified consumable. So my mechanical testing is only down to a macro. All right. So boom, that there you go. One macro goes in there. And then from that information there, we then go to our WPS. Now, the most important information in here is you've got everything now on your WPQR. The only thing you don't have now on your WPS is your variables, your upper and your lower in your current, your voltage and your travel speed and your heat input. So then you just fill all the details out as from your WPQR, and then you've just got to determine your upper and lower end in your current voltage, travel speed, and your heat input. And that's it.
Yeah, too easy.
That's how that works.
Right.
Now, what I think you will get is they sometimes throw in a WPS or a WPQR. It'll be a document sitting there, and there'll be information missing out of it. And you'll have to determine what's missing from it.
Yep.
So, be aware of the standard, the category, those sort of things, your material types, the standard that references, because when we look in 1554 part 1, you look at material types and it always references the standard above it.
Mm.
So when you're looking at a material, sometimes they'll often reference you'll find that they'll reference the standard and then the material, and then it's a matter of going through it and working out its steel type number and so forth from that, because that's where you're going to get your information. You've got to have that information, otherwise you can't work it out. You know what I mean?
Yeah, no drama. Yeah. I'll
So
work through that next couple of days and see how we go.
Yeah. Any dramas, mate, just email me and I'll help you out.
Yeah, and that's pretty much it. Yeah, it's just I just missed a bit of information on that. I'll just work through that, see how we go. The rest of it, yeah, I'm not going too bad. So
no, that's good.
Now just with say if, look, I'm sure other blokes in the same thing. Got pretty busy careers and the rest of it.
Yep.
Okay. Don't stop. If we're not ready for that December 10th exam date,
Yep.
can you contact them and say, look, I need some more time and do it next year or something instead of wasting time?
Yeah, I'm pretty sure you can.
Yeah.
Defer it.
Yep.
Yep.
And just defer it to like February or something like that. Like
Yep.
I'm hoping to be ready for it, but
Yep.
just in case. Yeah.
Yeah, no. If you don't think you're ready for it and you want to sit the next time, by all means, you know.
It just might need. I mean, I just get a bit more time to study.
Sometimes if guys fail this one, they'll, you know, this particular, the application standards, they'll resit it at the next time.
Yep.
Or they can organise the, you know, with the team in Sydney and organise a date to resit it.
Right.
So yeah, but you know, if you can just have one sitting and pass it, it's better.
Yeah.
Otherwise, you're gonna have to. It's another cost, you know. to
Yeah.
resit.
That's So I'm just finding out with my resit for my last exam.
Yeah.
Yeah, stop. Anyway, I think that was about it. Recent exam. No, it's all. I've forgotten what I was going to ask you. Anyway, I'll email you if we've got any other dramas.
Yeah.
Thank you very much.
So we've got tomorrow, Ryan.
Yep.
And we're going to go through 1554 part 6.
Yep.
That's the last standard. So you need 1, 4, 5, and 6 are the standards you require. And tomorrow the PowerPoint's a little bit bigger than what we've gone through today, because there is a little bit more information on stainless steels in there.
Right. Yep.
And naturally different steel groupings and so forth. So there is a little bit more extra little information in there, but the format is still the same. It's still set up identical.
Yeah. Actually, that was one of the questions. Do you know how many questions we actually got in the exam?
I think they're roughly around about 100, I think.
Yeah, right. Because I don't want to be practice things, just chipping through 14. And
Yeah.
like I'm quite behind on the times. It took me just under an hour just to slowly chip through and do them properly.
Yep.
And I was like an hour for 14 questions. Like, Jesus, I've got to speed up somewhere.
Yeah.
So that's where I'm just lagging a bit behind and just guiding through and probably
And
diddle-daddling.
And that's the thing, Ryan. What it is it's because of the small time frame, I suppose, you have with the standards so it is all about and that's hence why the notation is important, especially for assessment side of it.
Yep.
So if you understand the question fairly quickly and you know what section you should be in, by notating it, you get to that section really, really quick.
Yeah.
And then it's a matter of just searching for the answer in that section.
Yeah, right.
So
yeah.
The questions, you've got to read that question slowly and clearly to know what section you should be in.
Yeah, yeah.
And then once you're in the section, you'll know whether you're in the right spot or not.
Yeah, I did. Like I said, I've been finding out, like if I skip a question and I have been going through another section, I'll go, hey, there's that, like you said, there's that answer I needed.
Yeah.
I found that getting at the end of doing the last review questions, but
I
suppose just, like I said, I'm a little bit behind, just having to resit. I've put all my effort into trying to get that across the line.
Yeah.
I'm hoping to catch up in the next couple of weeks anyway.
Yeah, you'll be right. Like I said, notating them is a big thing.
Yeah.
Just helps you get there quicker. And also too, even when you have them notated and you're using them for work, you can access that part real quick.
Yeah.
All right.
All right, Ryan. Thanks for your time, Joe.
No worries, and I'll catch you tomorrow.
Yeah, no drama. Bye.
See you, mate.